Alright guys, so today we are going to be talking about aromatic nitration. And essentially what this reaction is we will have a benzene ring and we'll react it with HNO3, and also as a acid catalyst or secondary catalyst we'll have H2SO4, which is sulfuric acid. And what we'll get out of that is our benzene ring with the NO2 substituent. So here is the mechanism as follows. Alright, so first we need to prepare our electrophile. And that's just a fancy way of saying that we need a molecule that our benzene ring can attack. So first we'll bring in our HNO3. And we will react it with another equivalent of HNO3. So basically what's going to happen is that our oxygen right here that already has one bond to a hydrogen is going to depronate this hydrogen right here. Therefore, the electrons get moved on to this oxygen, and what we get out of that is an oxygen that will have essentially two bonds to two hydrogens. So this is our negative charge here, we have a positive charge on the nitrogen, and we have a positive charge on the oxygen. So now what we'll do is we will force out this part of the molecule because it's a good leaving group, which is water. So the way we do that is we take one of our lone pairs, since oxygen has three here, form a double bond, and that forces our oxygen to leave. So now what happens is that we have prepared a suitable electrophile, or a molecule that our ring can attack, and proceed with the mechanism. So now what's going to happen is that we are going to bring in our benzene ring right here, and one of those double bonds is going to attack our nitrogen there. Therefore, one of the double bonds on the oxygen is going to move back onto the oxygen itself, because nitrogen at most can only form 4 bonds. So now we bring this step over here, the molecule that's formed down here, we have our NO2 here, and our hydrogen here, and then we have a carbocation. Now this is a problem because we need to form a benzene ring, and the way we can do this is we can bring in our water that we had recently expelled earlier in the mechanism as a leaving group, and it's going to grab this hydrogen right here, and the bond is going to actually become a bond within our ring. So now what we have formed is our end product, in which we have our NO2 right here on our ring. And this could also just be written as the end product that we have up here, instead of drawing out all of the charges, which is just our NO2 right here. So the importance of this reaction is that NO2 is a substituent that would direct other substituents. And just to talk about it a little bit, it's basically a meta substituent. And what that means is that when you add other substituents onto the ring, it's going to be placed 2 spots away from our substituent that's already on the ring. So either here or here. So basically that is the complete reaction and mechanism for aromatic nitration. I hope this helps, have fun with it, and I'll see you guys in the next video.